Good morning, fellow students and Miss Seeger. Gianna, Grayson, and I are presenting a project which is a culmination of the work we did in Chapter 5.4 of the book, aka the washer method. To demonstrate our knowledge of this section, we are going to use the washer method to find the volume of a hypothetical volcano. In the washer method, we find the volume by adding up all the volumes of the cylinders that the hypothetical volcano is cut into. We cut the volume into infinitely many cylinders, and the volume of each cylinder is pi r squared h. This can relate to the washer method's formula, where the pi is on the outside, times the integral, meaning we're adding up all the cylinders together, times r squared, which is the right minus left of the hypothetical volcano. The r squared is right minus left because we rotated it to be the radius of that specific cylinder. All of that is minus the right minus left of the hole on the inside, which is the smaller piece. This would make the entire formula finding the big volume minus the little volume, with the big radius minus the little radius on the inside. Volume equals pi r squared h, so the h is the delta x, or d of x. This is because we have infinitely many cylinders, so our height is approaching a very small number.
So for this project, we were tasked with finding the volume of an object that we chose using the washer method. We chose to do a volcano. And so this is our graph of the volcano, and Gianna's going to explain how to do the math.
Okay, so like Grayson just said, the first thing you want to do is you want to make a graph, and for us, like he had said, we used a volcano. So we just made our graph and we chose the points that we wanted to use. So to get your points on the calculator, which is the easiest way to do it, you're going to go on your calculator, and then you're going to see a button that's like right here that's stat. You're going to click on that, and then first option is edit. So you're going to enter on that, and then there's this graph right here, and all you do is you just plug your points in. And then when you plug those points in from your graph, you're going to go back to stat, you're going to go over one to calculate, down to the fifth option, enter on that, and then when you get to there, you're going to want to make sure that the options L1 and L2, and then you just store regression, hit variable, you go over to the y function, you enter, and then that gives you your equation. While you're doing that, you want to make sure that your original graph, so this, has nothing else in it. Otherwise, you're going to get like this weird number, and it's not going to come out right. So then that brings you down to this, and basically it gives you your points. So now you have your equation and your points, and you're going to now find your zeros. So in terms of our graph, that went from 0 to 9.674. To show you kind of what's happening is this is the volcano right here. It's turning this way, so we want to find it from there and to there. So you go from 0 to 9.674, and you're going to use this equation. So we have the limit, which is from 0 to 9.674. Now we want to find the right minus 0 squared minus 1 minus 0 squared dy. So then that comes down to here. So you're going to take your equation and those points you got earlier, and you're going to put that in, and then you're just going to fill this in. So it's going to be negative 0.057 x squared minus 1.737x plus 0.754. And you want to box it. That's the easiest way so you remember what you're doing, because you want to combine this and then just leave that, because those two are going to go together. So then that's how we got to this step. And then you bring this over, and that's where your square root's coming from, and your negative's going to go over as well. So then you're left with all of this. These two will cancel out. So then you're going to bring this over, so that's why that becomes positive. And then this is the equation that you're going to plug into there. And now Grayson's going to show you the answer and why we know that's the correct answer.
Okay, so now we're finally left to solve. We took the equation that we had up here and plugged in the number that we found in step 4 right here. And with that, we were able to solve the integral to find our final answer, which is 3030.37. This may seem like a really big number. We know it's right because it's a volcano, and volcanoes tend to be pretty big. So that's our final answer. Thank you for watching our video.
We just want to say thanks from our group, which included Grayson, myself, and Tyson, who's camera shy and won't come in front of the camera today. But yeah, so now you should know how to do a washer method using a volcano or your own object. So thanks.
Yep, thank you. End video.
You're following me?
He turned it off.